question to you specific to bagging. Let's start from the sequence. So we hear about this, Bootstrap aggregating. So can you explain to me what is bagging, and specifically within bagging, what is that Bootstrap aggregating? What does it mean? It seems to be kind of fancy words. So could you just throw some light?
Sure. Absolutely, Nitin. Okay. So bagging, if you look at the name, has B and agging, right? So this is called as Bootstrap aggregating. B as in bootstrap and AGG as in aggregating, or ING as well. Here, once you have your data set, when you create training data sets randomly, and if you have, say, 1,000 observations in your underlying data, and if you're trying to take, say, 80% of data into your training, and if you're randomly doing that, say observation number 2 would be part of this. And when you try to sample the next observation, you will have all the 1,000 observations once again back in your data set. It's not that 2 is removed. 2 also would be there once again. So that means, once again, when randomly the observations are chosen, 2 also has equal chance of once again getting selected. That's called as bootstrap sampling. Bootstrap sampling means sampling with replacement. So whatever observation you take, you once again replace it back into your data set, and then randomly pull the next set of observations. Yeah. So that's called as bootstrap sampling.
So,
or bagging.
Okay, so obviously bagging is not as good as a scenario where we are sampling without replacement. I mean, are we in agreement on that, or are there certain advantages of other advantages of bagging in spite of sampling with replacement?
Okay, sampling with replacement and sampling without replacement are two different techniques that one can try out and figure out which technique actually works well. But usually sampling with replacement or without replacement do not have too many implications on the final outcome. But bagging works based on bootstrap sampling, which is sampling with replacement. Even without replacement, it doesn't matter much because it's just one observation, and the chance, as in how the underlying data, number of observations increase, with or without replacement will not have huge implication on what kind of data you are going to have on training.
All right. Okay. Yeah. So Sharath, next question I'm directing to you. So we've also discussed about the concept of processing. All right. So not mainly processing, but modeling. All right. So we discussed about certain models are sequentially processed, certain models are parallel processed. At a high level, we understand that sequence processing is slow, and therefore intuitively is considered to be better. Parallel processing is faster, but you may miss out certain things. Anything other than that you'd like to add with reference to the differences between sequential and parallel process models?
Yes, Nitin. So I would probably rephrase whatever you have mentioned. When we talk about bagging, those are parallel models. And when we talk about boosting approach, that's basically a sequential approach. I generally try and use an analogy. This is probably something everybody can correlate to, especially graduates. When you're trying to write your final exams, we generally, as a group, try to study. And probably before the exam, a day or 2 days, we generally distribute the units. We say that, hey, friend one, you discuss, you study chapter 1, I will study chapter 2, someone else studies chapter 3. And basically what happens in the exam, the discussion that happens, right? So individually, everybody is studying individual chapters. And when the exam actually happens, the capacity, the performance basically comes as the group study. So it's like all the individual friends discuss about their individual chapters that they have prepared and then write the exam. This is the analogy of bagging, where you're trying to do parallel studies, but on subsamples of data. Right? So the chapters here are basically nothing but subsamples that I'm trying to draw the analogies. And in each friend is like a machine learning model that we are talking about, a tree-based algorithm. Whereas boosting is a sequential approach. And you can, again, talk about that one student who's always doing best in the class. His IQ levels are good. He is probably sitting in the first bench, right? So these students basically try and learn the subject by reading everything by themselves. So what they do is they take the first chapter, try and understand all the concepts. They may not be able to understand everything, but what they do is they try to go to the next chapter after the first chapter is finished. Chapter 2 is basically being now studied. They will try to also understand what is the concept which they couldn't follow in chapter 1 when they are preparing for chapter 2. So that they try to redo the chapters. But eventually, the same student is trying to study the entire subject. So this requires time. Obviously, if you have 10 chapters, you have to sequentially go through. Whereas when we talk about parallel, each student is studying one chapter. So all of them can distribute the work and then study. So the duration definitely comes down in the parallel models, that is in the bagging approach. And in sequential approaches, duration is generally the concern. But thanks to the distributed frameworks that we have, the infrastructure capabilities that we have, extreme gradient boosting is an approach which can quicken, right, this entire process. It can fasten up the entire process of sequential learning as well. So, but again, you need to have multiple processors to get this thing done. So this is the major difference between bagging and boosting that I would want to make a point of.